Topic 4.5, we have the shear and moment functions. So, sa previous natin na topic ay napag-usapan natin kung paano tayo mag-compute ng mga internal loadings. And then here, ay magkakaroon tayo ng series of investigations regarding the internal loadings in each segment. So, paano natin madidetermine yung bawat segment? So, for the uniformly distributed or uniformly varying load, so for this entire load, for the uniformly varying or uniformly distributed load, we take this as one segment, and another segment from the end of the UDL or UVL to the point load, and from the point load to the other support. Now, in order for us to expose the internal loadings in between the segment AB, so we are cutting this, and that distance is what we call the arbitrary x sub 1, wherein this x sub 1 here is the limit which runs from 0 up to point B. And if we are going to cut this beam here at this point, so not specifically on that point, because this x sub 2 would be running in between point B and point C, so that x sub 2 here is any value from B to C. And another cut after the load P, so another segment CD, to represent the CD, we are cutting this beam here, and that is the arbitrary distance x sub 3, which runs from point C to point B. So, ano yung magiging itsura niya kapag kinat natin siya? For the segment AB, so it would go like this. So, for segment AB, so since we are cutting in between A and B, so ito yung mangyayari sa kanya. And at this point A here, this would have a reaction. So we have here the RA. So since usually yung actual load, if there is the reaction AX, it would not affect your shear and moment diagram. Doon lang tayo sa mga loads wherein we are just taking the vertical, in this case, yung mga vertical loads lang yung makaka-apekto ng shear and moment diagram natin. Yung mga horizontal na reactions would not affect our shear and moment diagram. Now, since we cut this segment AB here, so that distance x sub 1 would be taken between A and B. So this distance here is our x sub 1. Now, since we cut, it would now expose the shear, the moment, and the actual load. So, from this ay makukuha natin yung shear and moment equation. And that is the shear and the moment function. So, given is the equation, you're just going to substitute any value between A and B, then you would be able to solve for the shear and the moment in the section AB. Then, if we are going to cut in the segment BC, then magkakaroon tayo ng ganitong itsura. So, since we are in BC, buo na ngayon itong AB. So, we have... So, since the segment BC is any point between this B here and C, so we have here x sub 2, and so of course this is segment BC. And then here we have the internal loading. This is the shear. We have the moment and the normal. So from this ay i-determine ulit natin yung shear and moment function, and then if we are going to substitute any value So since we are already in the segment BC, then this x sub 2 here is any value between the B to C. So, question, pwede ko bang i-substitute sa equation na makukuha ko dito sa shear in the moment yung distance between A and B? The answer is no. No? Kasi ang pwede ko na i-substitute na value sa kanya is the distance from B to C. Because this equation here in the segment BC is only valid for the segment BC. For the distance natin, para dito kay segment AB, ito naman yung gagamitin nating shear and moment function para sa pag-determine natin ng shear and moment sa segment na to. So for the segment CD naman, since nandito tayo nag-cut, so lahat ng nakikita natin sa left side na to ay makikita natin dito. So, we have here so this is A, B, and this is C. Ayan. So since nagka tayo dito and that distance is now the x sub 3, this distance x sub 3 here is any value between the point C to point D. And so from this, may expose yung mga internal loadings. So we have the shear and the moment and the normal. So we are much concerned with the shear and the moment. So yung normal, hindi na natin dito kinoconsider para sa ating shear and moment functions. So, pagdating natin sa frames, ibang usapan na yan, lalo na kapag meron tayong mga naka-include na members. So, we have now the equation for the shear and the equation for the moment. So, substitute lang natin sa equation ng shear natin yung any value between C and D. Then, we will be able to compute for the shear for the segment CD. And, of course, the same with the moment. Isa-substitute lang natin yung distance, no, in between the point C and the point D. Then we'll be able to compute for the moment of the distance CD. Let's start with the very basic na example. So far, ito yung pinaka-basic na example sa lahat. The case wherein we have a simply supported beam and we have the concentrated load P at the midspan. So if this is distance L, therefore this is L over 2 and this is L over 2. Pangalanan natin yung left support natin as point A and this location where the load B is applied as B and this is C. Now in this case, we would have two segments, the AB and the BC. So first thing that we are going to do, of course, is to compute for the reaction of the supports. So for the reaction of the supports, we have here RA and we have here RC. Now for this, since this is a hinge, of course we are expecting RAX here, but we don't have a horizontal load, so this would just be equal to 0. So the usual thing that we are going to do here is we are going to summate moment at point C is equal to 0, taking the clockwise direction as positive. So what we have here, RA multiplied by the distance L minus P multiplied by the distance of L over 2 is equal to 0. Then we have RA multiplied by L is equal to PL over 2. So RA will be equal to, so L will be cancelled and RA is equal to P over 2. So if we are going to summate forces vertical is equal to 0, then we would have here RA minus P plus RC is equal to 0. And since RA is equal to P over 2, so we have here P over 2 minus P plus RC is equal to 0. And this is equal to negative P over 2 plus RC is equal to 0, then RC is equal to P over 2 also. So by rule of thumb, if we are not going to do this solution here, we know that the load B is in the midspan. So, paghahatian lang yung load ni RA at saka ni RC. So, without the computation, we know that the RA is just half of the load and the RC is also half of the load B. So, if we are going to do the shear and moment function, we are going to cut in this segment here now, and this would be the distance x sub 2. So for segment AB, we have here the support. Of course, they don't have the load, and you cut this point, and this is now the x sub 1. So in here, you have the reaction RA. The RA is equal to P over 2. So at this point, of course, you have the shear and you have the moment. So hindi ko napakita si normal. And this segment here is between A and B. So for the shear, we have here shear is equal to P over 2. So meaning at x is equal to A, your shear at A is equal to P over 2. Since as you can see here, this B is equal to P over 2, so this is constant. So meaning the shear from point A to point B is just equal to P over 2. So if x is equal to B, so the shear at B is still P over 2. How about the moment? So for the moment, that is equal to, so in the moment we are taking the clockwise direction as positive. So if we are going to take moment, we are taking the moment at the section. So if we are going to take the moment here, then we have here the P over 2 multiplied by x sub 1. So that will rotate clockwise, so that's positive. So it's Px over 2. Now, if x is equal to A, wherein A here is equal to 0, therefore the moment at A is equal to 0. And if x is equal to B, wherein the point B here is located at L over 2, therefore if we are going to substitute in here the L over 2, then you would have the moment is equal to PL over 4. Why? Because if x is L over 2, so that's 2 times 2, it's 4. Now, for the segment BC, so at this distance L over 2 here, we have the load P here, and this is now the distance x sub 2. So for the reaction, we have here at the support, this is P over 2. Now we have here the shear, and we have here the moment. So this distance here, x sub 2, is between the point B to point C. And since your point B here is L over 2, so that would run from L over 2, and the point C is L. Okay, so for the shear, we have here shear is equal to, this is upward, so it's positive, P over 2, and this is downward, so minus P, that's negative P over 2. So meaning, if x is equal to L over 2, that is in point B, the shear at B is equal to negative P over 2, since we have here constant. So if x is equal to L, the shear at point C is also equal to P, negative P over 2. Now, how about the moment? So for the moment, we have here the P over 2 multiplied by this distance here, since we are taking the moment of the section, of the cutting plane, or the cutting section. So we have here P over 2 multiplied by the distance x sub 2. And this P here would create a counterclockwise rotation. And this distance here is x sub 2 minus L over 2. So we have here minus P times x sub 2 minus L over 2. So we have here the moment is equal to P over 2 x sub 2 minus P x sub 2 plus PL over 2. So simplifying this, and we would have moment is equal to negative P over 2 x sub 2 plus PL over 2. And if we are going to substitute our limit, if x is equal to B, which is equal to L over 2, so x is equal to B, wherein that is equal to L over 2, then we would have the moment is equal to negative P L over 4 plus PL over 2, and that will give you PL over 4, which is also the same as this. And if x is equal to C, that is equal to L. So moment is equal to negative PL over 2 plus PL over 2, and that would give you moment is equal to 0. Now, paano natin na-drawing yung shear and moment diagram nito? So we would have the load P here, we have the reaction P over 2 here, and we have another reaction P over 2 here. This is segment A, B, and B, C. So we have, if this is the shear diagram, so this line here is 0. So the positive shear would go upward and the negative shear would go downward. Okay, so sketch natin. If x is equal to A at this point, so that's x is equal to 0, the shear is equal to P over 2. So meaning at this point here, the shear is equal to P over 2. And at x is equal to B, so at this point, wherein the B is equal to L over 2, the shear is still P over 2. So meaning this is constant P over 2. So since the shear is P over 2 from point A to point B, so meaning this is just a straight line, no? So constant yung equation natin. And pagdating natin dito sa segment BC, we have at x is equal to L over 2, we have the shear which is negative P over 2. So meaning pagdating dito, siya ay negative P over 2 na. Sa segment BC na tayo ha. And at x is equal to L, still that's negative P over 2. So we have here negative P over 2. So meaning constant, no, yung ating shear from point B up to point C. Now, paano siya magko-close? Ito yung reaction na P over 2 upward. Siya yung magsasara ng ating shear diagram. So therefore, this is our shear diagram. So how about the moment diagram? So we have here, at x is equal to 0. So dito tayo kay moment ha. At x is equal to 0, the moment is 0. So we have here, the moment is 0. At x is equal to B, the moment is PL over 4. So at this point here, we have PL over 4. And the same, at x is equal to B, we have here PL over 4. So usually ito yung ginagawa nating pang-check na kapag nandito ka dapat yung moment mo dun sa previous na solution mo is equal, no? If yung beam mo ay wala namang load, no, na couple. So, pag merong load na couple, then hindi na siya magiging equal kasi it would change your moment diagram upward or downward. At that point lang na kung saan applied yung couple. So, we have the moment is equal to 0 at x is equal to L. So, this is equal to 0. So, as you can see here, we have the linear equation, and meaning this is just equation of a line, no? And as you can see here, we have the positive slope, no? So, it's inclined to the right. And we have here the negative, no? The slope. And this is also a linear equation, so meaning this is just a line. And this is now our moment diagram. So, shear and moment for beams. If we are going to consider this loading here, and iti-take lang natin itong segment na to, wherein that is the delta x. So, in this case, we would expose the internal loads, no? If so, dito, ito yung part na to na in-isolate natin. Of course, at this point here, you have the moment M and you have the shear V. And of course, since we have here the load, this load here is the WX. So, this distance is delta x, and since from this point to that point we have the change in distance and we would have the change in moment. So at this point we have here the shear, this shear here, plus the change in shear. And for the moment, we have this moment here plus the change in moment from this point to that point. So for the load, we have here the resultant of the load, which is just the area of our load diagram, that is equal to Wx multiplied by the distance delta x. Now, the location of this load here is the centroid, and we refer this distance here, our centroid, as the epsilon delta x. If we are going to summate forces vertical is equal to 0, taking the upward direction as positive, then we have here the shear V minus the resultant of the load, that's Wx multiplied by delta x, and this one here, so minus the V plus the delta V is equal to 0. Now simplifying this, and we would have V is equal to Wx delta x minus V minus delta V is equal to 0. We would have this V and the negative V cancelled. So transpose this on the other side of the equation, then we have here the delta V is equal to negative Wx delta x. Now if we are going to summate moment at this point O here, then we have here summation of moment at O is equal to 0, taking the clockwise direction as positive. Then we have here the moment that would create a clockwise rotation, so that is positive, plus this shear here would create a clockwise rotation also, and it has a distance of delta x, so we have here V delta x. This load here, Wx delta x, would create a counterclockwise rotation, so we have negative Wx delta x multiplied by the distance E delta x. Itong shear na to would not create a moment, so therefore this would not be considered, but this moment here will be considered, and it is counterclockwise, so we have your negative moment plus delta m, and this is equal to 0. Now simplifying this, and we have m plus v delta x minus w x delta x e delta x minus m minus delta m is equal to 0. So we have our moment cancelled, and let's transpose this on the other side of the equation. It would make the delta m positive is equal to this v delta x minus w x e, and the delta x times delta x here would be delta x squared. Okay, now this equation here is our equation 1, and this is our equation 2. If we are going to divide our equation 1 and equation 2 with the delta x, then we would have for our equation 1 as delta v is equal to negative w x delta x, and this is over delta x, and this is over delta x. So we have here dv over dx is just equal to negative wx. So what would be our generalization from here? We have the dv over dx as the slope of the shear diagram. So this dv over dx here is the slope of the shear diagram, and this is just equal to the negative intensity of the distributed load, as you can see here. So it is just the negative intensity of distributed load. And for this equation here, we have the delta m over delta x is equal to v delta x minus w x e delta x square over delta x. Then we have here the dm over dx is equal to v minus w x e delta x. But if we are going to take the limit as delta x approaches 0, so meaning this would be 0, so we have now the dm over dx for the change in moment is just equal to the shear. So what does this imply? So we have here the slope of moment diagram is just equal to the shear. Now from this generalization here, we know that the slope of the shear diagram is the negative intensity of the distributed load, and the slope of the moment diagram is equal to the shear. So balikan natin tong kanina. So we have the slope of the shear diagram is equal to the negative intensity of the load. So what is the slope of the shear diagram at this point? That is equal to 0, and as you can see here, you don't have the load at that point. The slope here is equal to 0, and you have the 0 load at this point. So we have the slope of the moment diagram is just equal to the shear. Now, so what is the slope of the moment diagram here? As you can see, titake natin yung slope nito, ng line na to. So it is just the rise over run, right? So we have the rise, that's PL over 4, and the run is L over 2. So it's L over 2, and that would give you the P over 2. Wherein, yung shear natin from this point to that point is equal to the shear P over 2. Now, for this line here, we are going to take the slope. So, since as you can see here, we have the line inclined to the left, so that's negative, no? So we have the negative slope, PL over 4, that's the rise, and the run here is L over 2. So we have here the slope of negative P over 2, and that negative P over 2 is the shear from this point to that point. So what about if we have a uniformly distributed load over the span? So let's see. If we have the uniformly distributed load over the span, and this load here is W, so of course we have here the reaction at point A and the reaction at point B if this is segment AB. Now, if we are going to recall from the previous derivation that the slope of the shear diagram is just equal to the negative intensity of the load, then the slope of the moment diagram is just equal to the shear. Now we have here dV is equal to negative Wx dx, and the delta M is just equal to the V dx. And if this equation now can be integrated from one point to another between concentrated forces or couple, in which case we have here the change in shear is just the negative integral of Wx dx, and the change in moment is just the integral of the V dx. Now, as you can see here, we have the change in shear is just equal. So, anong sinusolve natin pag nag-integrate tayo? So, that's the area. It is the negative area under the area of the load diagram. Then, for the change in moment, that is just equal to the area under the shear diagram. Now, kung babalikan natin yung previous na example natin, we have here, if we are going to take the integral of this equation, nung load diagram natin, then the area is just, so the shear is just the area of the load diagram, and the moment is just the area of the shear diagram. So, kung titingnan natin, we have here the load P, we have the reaction P over 2, and the reaction P over 2. Now, kung makikita natin dito, for the shear diagram, we have the upward force P over 2, so it would take the diagram upward, that's P over 2. As you can see here, you don't have the load from this point to that point, so meaning you just have the constant P over 2. So since wala ka namang area in between, now this load P here would push the shear diagram downward, so it's P over 2 minus P, so that would bring you to negative P over 2. And at this point to that point, from the segment B to C, kung i-represent natin siya ng segment, you don't have the load from B to C, so meaning this is just constant. And pagdating dito, so that P over 2 would close your shear diagram. So that would be the shear diagram, just equal to this shear diagram using the function of x kanina. Now, for the moment diagram, ang sinasabi doon that the moment at any point is just equal to the area of the shear. So if we are going to take the moment at this point, it is just equal to this area here. So what is the area? Area is just the P over 2 multiplied by L over 2. So P over 2 times L over 2, that's PL over 4. And it is the area of this shear diagram here that is equal to the moment at that point. So from this point to that point, so you have here a line. So always remember that if you are taking the integral, since we are integrating here, you always, no? So tingnan natin ha. If we have the integral of dx that is equal to x, wherein if we are going to take the integral of x dx that is equal to x squared over 2. So as you can see here, your equation would be added by n plus 1 from the formula, right? From the general power formula, that you have the x raised to n plus 1 over n plus 1. So meaning the degree of the equation increases by 1. So as you can see here, we have the horizontal line. This has the degree 0. And this is after taking the integral, since we computed the area, no? So we have here the degree 1 equation, and this is linear. Now, since we already have the moment at that point, which is PL over 4, this is the moment at this point, we subtract, no, this area 2 here, since this is a negative area, so minus area 2, and the moment here would be equal to the moment at this point C. So we have PL over 4 minus this area here is negative PL over 4. So meaning the moment at C is equal to 0. And since this is degree 0, this would be n plus 1, a linear, no? This is a linear equation. And we have here our moment diagram, which is just equal to this moment diagram here. So balikan natin ito. So taking the area of the load diagram, so we have here WL. So by rule of thumb, since this can be found at the midspan, so therefore paghahatian lang siya ng dalawang reaction, and this is WL over 2 and this is WL over 2. Now if we are going to make use of the idea that the shear is just equal to the area of the load diagram. Now, as you can see here, at this point, so RA is upward, so that's at this point, this is WL over 2. And this area here, which is the resultants, now, as you can see, if this is L over 2, if this has the intensity W, so we have here the WL over 2, and this is downward. Sinasabi dito that it is the negative area of the load diagram. So we have here the WL over 2 minus the WL over 2, and that would give you 0. So this is degree 0, so meaning dito. So we have here a linear equation, no? And this is degree 1 after integrating. Now, this area here is WL over 2 also. So we have here 0 minus WL over 2, and that will give you negative WL over 2. So still, we have here a line. And this is a degree 1. No? So we have here WL over 2 upward. So yun yung magpapaklose, no, dito sa ating shear diagram. And this is now the shear diagram. For the moment diagram, we are just going to compute this area here in order for us to compute for the moment at this point. So this area ay tatawagin natin area 1. So we have here our moment. This is 0. So the moment at this point is this area 1. So area 1 is just equal to 1/2. The base is L over 2 and the height is WL over 2. So we have here area 1 is equal to WL squared over 8. So meaning this moment here is WL squared over 8. And how about for the curvature? Since we know that this is degree 1, so we are expecting degree 2 curve here. So it's a parabola. But we don't know whether our parabola is facing downward or the parabola facing upward. No? So, what we are going to do, pag-uusapan natin ngayon kung paano mag-bend ng curve. So, in here, we have this code, tatawagin natin dy ix. No? Ano yung ibig sabihin ng dy ix? Pag decreasing, i-bend natin yung y-axis. Pag increasing, i-bend naman natin yung x-axis. So, paano natin ma-determine which is the x-axis and which is the y-axis? So, always take this first point here as the origin and this second point here, no, na nandun sa quadrant natin. So, we only have two options. Kasi palagi namang yung nasa left, no? Palagi yung nasa left yung origin natin. So, yung point natin could be here or could be here. So, it could be in quadrant 1 or it could be in quadrant 4 since yung shear diagram, since yung moment diagram natin or yung shear diagram natin is from left to right. So, this would be the x-axis and this would be the y-axis. Decreasing, we have to bend the y-axis, no? So, if this is the next point, this is the y-axis. So, pag binend natin siya, so ito yung curvature natin. Now, if it is increasing, bend the x-axis. If this is the point in quadrant 1, yung x-axis yung ibibend natin, ito naman yung magiging curvature niya. Now, if the next point is in quadrant 4, and if we are going to bend the y-axis, ay ito naman yung magiging itsura niya. Now, if it is increasing, bibend natin yung x-axis, then ito naman yung magiging itsura niya. Ngayon, paano natin malalaman kung decreasing o increasing ba? Ang magiging basis natin, if we are going to determine the curvature here in the moment, ay titingnan natin yung shear natin, whether it is decreasing or increasing. So, ano yung magiging ruling natin sa decreasing or increasing? Always take from left to right. So, ito yung mukha. If this is the load, so whether it is positive or negative, no? If this is 0, whether it is positive or negative, from left to right, we consider this as decreasing. Kasi simula sa dito sa kaliwa, papunta ng kanan, lumiliit ng lumiliit, it's decreasing, no? So, kung trapezoidal man to, from left to right, as you can see, siya ay lumiliit. So, therefore, this is decreasing. Kahit na siya ay negative, no? From left to right, still, kung makikita mo, it's decreasing. So, therefore, this is decreasing. Yung increasing naman is from left to right, ito yung mukha. Kahit na negative yan, from left to right, lumalaki siya, still, it is increasing. Now, for trapezoidal, kung positive, ito yung mukha, it's increasing. So, kahit na negative siya, from left to right, it's increasing. Kung makikita natin dito, our shear here is decreasing. So, galing siya ng WL over 2 naging 0. So, since decreasing siya, so we have to use the dy. So, decreasing, bend the y-axis. So, in this case, this is in quadrant 1, no? So, ito yung y-axis natin. And this is our x-axis. So, dy, bend the y-axis. Then, this would be your curvature. Not this one. No? So, from this point to that point, since your moment here is WL square over 8. And if we are going to take this area 2 here, this area 2 is just the negative WL square over 8. So WL square over 8 minus WL square over 8, and that will give you 0 here. Kaya ito naman yung sinasabi ko. Ito yung nasa left side, siya yung magiging origin. At ito, yung magiging nasa quadrant 4 na siya. So in this case, yung x-axis natin ay ito at yung y-axis natin ay ito. So in this case kasi, galing tayo dito, papunta tayo dito. Sa nauna natin kanina, galing tayo dito, papunta tayo doon. So ito yon, papunta doon. So ito yon, papunta doon. Ngayon naman, galing tayo dito, papunta doon. So dito, papunta sa quadrant 4. Kung titingnan natin, ibibend natin, sino ibibend natin? So, sabi ko kanina, whether it is positive or negative, as long as from left to right, makikita natin na siya'y lumalaki, meaning it is increasing. So, increasing, bend natin yung x-axis. So, in this case, this is the x-axis. This would be the curvature, not this one. Okay? So, this would be our moment diagram. Ngayon, balikan natin yung sinasabi nito. The change in shear is the area, negative area under the load diagram. So the change in shear, meaning the slope. The slope of this shear diagram is the load, the negative of the load. So ano yung slope nito? If we are going to compute for the slope, then we have here the rise, which is WL over 2, and the run, which is L over 2. Then we have here the, since this is negative, no? Negative, makikita natin. So it is the negative. So negative W, no? So ito yun, yung nakukuha natin. It is the intensity of the load, no? And how about this one? Kung makikita natin dito, if we are going to take the slope of the moment diagram at this point, we just compute for this shear here, no? That is equal to the slope at that point. Ngayon, if the shear is equal to 0, so it only implies that the slope at this point is equal to 0, diba? So the idea of the minima and the maxima, the point where the moment is maximum, the slope is equal to 0, no? So the location of the zero shear is the location of the maximum moment.